as I was saying before my phone died, the big one is the total. The small one is the number of protons. Okay? If anything, we don't actually need the small one because I know if that's C, it must have 6 protons. In the same way that I know if it's gold, it must have 79 protons. Okay, that number there is just how many protons there are. Let's put it in there. Now imagine I could magically get that and replace it with a proton. What would happen here? Well, I've now got 1, 2, 3, 4, 5, 6, 7. I've still got 14 overall. But hang on, it's now nitrogen. So carbon 14, if I do that bit of magic, can turn into nitrogen 14. And I can do that if it makes sense. Okay? Carbon 14 isn't very stable for some reasons we'll go into. Nitrogen is, so it's become unstable to stable. However, my bit of magic needs explaining and will get explained in 2 weeks' time. Unstable to stable. It basically gives off something to become stable. And that something it gives off is radiation. Okay? So from that, right, what we've done, we've talked about isotopes. Like I said, I'll link a better video into it. Okay? Now, just finally, since I've got you here, alpha, beta and gamma. Alpha, beta and gamma. Okay? An alpha particle is just a helium nucleus. Okay? In fact, I think we're going to save this for next week. This week, I wrote down on a Word document what I want you to do. It's basically a bit about the Bohr model. Okay? It's watch a few videos. I want you to complete the table on relative and actual charges and mass of protons and neutrons. I want you to tell me what an isotope is, what is a stable isotope. And we don't have to say what this has got to do with radiation. In fact, don't go for stable isotopes. We'll talk about it more when we do alpha. I need to know that you know what an isotope is. Basically, follow the instructions in the Word document. More videos to follow next Tuesday. Next Tuesday is all about the alpha particle. Cool. Have a good week. Stay safe and everything. Ta-ta.